All right, let's try a question where we're trying to decide which way will the equilibrium shift. And yes, we have done questions like this in class already, but we didn't really get a chance to practice. So I just want to go over one as a group. So got a reaction here, N2, 3H2 goes NH3. I know these concentrations are this much is initial concentrations. So is the reaction at equilibrium? Oh, and I'm given the K up here. Boom. So first thing I'm going to do is I'm going to write the equation for KEQ and its products over reactants. I'm going to plug in. Actually, I should rewrite this as the reaction quotient Q. It would be technically incorrect to plug in anything here other than equilibrium concentrations. And these are not equilibrium concentrations. So I'm going to plug in here. I'm going to get 1 times 10 to the minus 3 squared. I'm going to get 2 times 10 to the minus 3 cubed. And I'm going to get 1 times 10 to the minus 5. And I do this math, and I get 1.25 times 10 to the positive 7. Now, the actual is 6.01 times 10 to the minus 2. So if this thing was at equilibrium, which is what it's asking for, I would have just got 6.01 times 10 to the minus 2. I did not. Therefore, not at equilibrium. Which way is it going to go to get there? Well, let's take a look. Right now, this number is too big. It must get smaller. Must get smaller. How do I get this fraction smaller? To get this smaller, this has got to get smaller, and these have got to get bigger. So therefore, we'll shift left to reach equilibrium. Again, right now, way too big. It's got to get smaller. NH3 has to get smaller. These have to get bigger. Got to get smaller, has to get bigger. Reaction's going to go, ooh. Say that again. It's got to get smaller. This has got to get smaller. These have to get bigger. So the reaction's going to shift left.